The sweetest compound among the following is, we have saccharine, sucralose, aspartame and L-etine. Basically in this case we can compare the sweetness of these artificial sweetening agent with sugar. So if we talk about saccharine, this is 550 times sweeter than the normal sugar. If we talk about aspartame, that is 100 times sweeter than the sugar. And then sucralose is there. Sucralose is 600 times sweeter than cane sugar. Then if we talk about L-etine, this is the sweetest one because it is 2000 times sweeter than the cane sugar. That is why this option 4 is the correct option for this particular question. And yes, the turn is there for question number 67. Question number 67, which among the following is an analgesic? If we talk about aspirin, aspirin is analgesic as well as antipyretic also. So this is analgesic. I'm just writing here, this is analgesic. What about Equanil? This is tranquilizer. Then ofloxacin and salvarsan. These two are the antibiotics. So, which is the correct answer? Definitely aspirin is the correct answer. That is an analgesic. And option 1, you can easily choose as the correct option. Let's check next question. Question number 68. The compound which is optically active is. What are the conditions of optical activity? We know that if certain compound contains chiral carbon, it means asymmetric carbon is there, then definitely it would be optically active. But in certain compounds, due to the presence of elements of symmetry, compounds becomes optically inactive. So we just have to check the given compounds first. If we talk about the option 1, this is an allene. And if we talk about an allene which is properly substituted, in that case it would be definitely optically active. But here if we talk about this allene, in this case there are two methyl groups which are present here, and these are making here the plane of symmetry, and that results in optical inactivity in this compound. Now let's check the next option, that is option 2. In the option 2, this compound is given in which two phenyl rings are there. So we know that due to the rotation of bond, these two phenyl groups are in the different plane. It means it can be chiral, it can be optically active, but due to the presence of two methyl groups at the ortho position, making here the plane of symmetry. And if plane of symmetry is there, definitely optical activity would not be there. It means it is also not optically active. The first one also not exhibit optical activity. Now third option we have. In this case, we can see here the chiral carbon. There are two chiral carbon you can observe, but again there is the plane of symmetry that you can even identify. And yes, in that case, it becomes optically inactive. Now let's see the next option also. In the fourth option, if you look here, this is the compound where neither plane of symmetry is there, as well as it has two carbon atoms which are chiral. And that's why this is exhibiting the property of optical activity. And we can choose it as the correct option for this particular question. And now after this, let's move on to the next question. Question number 69. Which among the following will have highest probability to undergo nucleophilic substitution reaction by SN1 mechanism? It means you want to identify that particular compound which is participating in SN1 mechanism for completing nucleophilic substitution. So we have different options given here. First is the methyl chloride. The compound is CH3Cl. Then we have tert butyl chloride. What is that tert butyl chloride? This is tert butyl chloride. Then chlorobenzene is there. And further ethyl chloride. So this ethyl chloride is, this is ethyl chloride. Now, if you just look at the option 2, the tert butyl chloride, this compound will follow SN1 mechanism. Now your question would be there, why it is following SN1 mechanism? Because in this case, when it follows SN1 mechanism, there is the formation of a tertiary carbocation. It will result in the formation of tertiary carbocation. This would be formed here. This is the most stable one. Definitely it will follow SN1 mechanism. And that is why we can choose this tert butyl chloride as the correct option. It would have the highest probability to undergo nucleophilic substitution by SN1 mechanism. Now, after this, question number 70. Question number 70, consider the following reaction. We have the given reaction sequence. In the first reaction, there is haloalkane that is reacting with alcoholic KOH. What type of reaction it is? It is beta elimination reaction, and the product A is formed as the major product. What is that? That is alkene. Now, on this alkene, when hydration is done, another product B is formed. Definitely it would be alcohol, but you have to identify that B which is formed here. Let's check what will happen during this reaction. And the reagent is the nucleophile that will attack over here. So in this carbon it will attack. There's the shift of electron, and ultimately here's the formation of the product that is an alkene, because these electrons are also. So finally this product is formed. This is product A, but this is not the reaction. Further, its hydration would be done, acidic hydration. So when H plus ion attacks on it, so this would be added here. So this is the intermediate which would be formed, but this is unstable. So what will happen? There is the hydride shift, and during hydride shift there is the formation of more stable carbocation. CH2, CH3. This is tertiary carbocation that is more stable. And then what will happen? When water is added to it, there is the formation of the final product that is an alcohol. This is the final product. If you look at the given options, you will identify that the compound given in option 2 is the correct option. So I'm just marking it as the correct answer. Option 2. I hope this question is clear to you.